Welcome to UGC lecture series in computer science on software engineering. We are seeing a series of lectures. In this session, we will be seeing about system design diagrams and the strategies of system design. Now, let us see what a system design is. A system design is a systematic process which includes phases such as planning, analysis, design, deployment, and maintenance. It is a process of planning a new business system or replacing an existing system by defining its components or modules to satisfy the specific requirements. Before planning, you need to understand the old system thoroughly and determine how computers can be used in order to operate efficiently as well effectively. The system design is the phase that bridges the gap between problem domain and the existing system in a manageable way. This phase focuses on the system domain, that is, it says how do you implement. It does not say what you are going to implement, it will say how do you implement or how to implement. It is a phase where the software requirement specification document is converted into a format that can be implemented and decides how the system will operate. In this phase, the complex activity of system development is divided into several smaller sub-activities which coordinate with each other to achieve the main objective of system development. Let us now see the overview of the system design. Anything and everything, you are supposed to identify the design goals, and the system decomposition has to be identified. Decomposition, what do you mean by decomposition? It is splitting it into equal halves. So system decomposition has to be identified, and concurrency has to be identified. Hardware allocation has to be verified. Data management has to be identified. Global resources has to be identified, and the how do you implement your software, what sort of control measures that you take when you are going to do the implementation part has to be jolted down. Then what are the boundary conditions, what is the environmental factor, how it should work and how it should not work has to be identified, and those things has to be noted, and it is said to be the boundary conditions. Then let us see the inputs to system design. The system design takes the following inputs. One is, it has the statement of work, requirement determination plan, current situation analysis, proposed system requirements including a conceptual data model, modified data flow diagrams, and about the metadata. My dear students, what is a metadata? A metadata is data about data. What does it mean? What do you mean by data about data? It has all the information related to that particular data. That is called as data about data, which is as well called as metadata. That is a data that contains all information, you call it as a metadata. Now let us see the outputs to system design. System design gives the following outputs. They are infrastructure and organizational changes for the proposed system, a data schema, often a relational schema, metadata to define the tables or files and columns or data items, a function hierarchy diagram or web page mapping that graphically describes the program structure, actual or the pseudocode for each module in the program, a prototype for the proposed system. So these are some of the outputs that are required to the system design. Now let us see what are different types of system design. You have the logical design, physical design, architectural design, detailed design, conceptual data modeling, entity relationship model, and we will be seeing about the file organization. So these are all said to be some of the types of the system design. So first let us see about what a logical design is. A logical design pertains to an abstract representation of the data flow, inputs and output of the system. It describes the input, that is, input means the sources, and the output. Output here denotes the destinations. Databases are stored in the data stores. Procedures, data flows, all it will be kept in a format that meets the user requirement. And this logical design will encompass the data flow diagram, entity relationship diagram, which is shortly and fondly called as ER diagram or used. Now let us see details about the physical design. The physical design relates to the actual input and output processes of the system. It focuses on how data is entered into a system, verified, processed and displayed as output. It produces the working system by defining the design specification that specifies exactly what the candidate system does. It is concerned with user interface design, process design and data design. Now let us see about the architectural design and the detailed design. So architectural design is also known as high level design that focuses on the design of system architecture. The architectural design, usually the high level designs will tell us what is to be done, whereas the low level design will explain us how it is to be done. So this architectural diagram or architectural design is a high level design that focuses on the design of system architecture. It describes the structure and behavior of the system. It defines the structure and relationship between various modules of system development processes. The detailed design, what is detailed design is about? The detailed design follows architectural design and focuses on development of each module. Next, let us see about the conceptual data modeling. The conceptual data modeling is a representation of organizational data which includes all the major entities and relationships. System analysts develop a conceptual data model for the current system that supports the scope and requirement for the proposed system. The main aim of conceptual data modeling is to capture as much meaning of data as possible. The most organizations today use conceptual data modeling using the entity relationship model, which is shortly called as the ER model, which uses special notation to represent as much meaning about data as possible. Before we could see the notations or the special notations used in ER model, let us first know what the entity relationship model is all about. Entity relationship model is a technique used in database design that helps describe the relationship between various entities of an organization. The terms used here is shortly as E-R model. E denotes entity and R denotes relationship, and ER model denotes entity relationship model. Now, what is entity? Entity specifies distinct real world items in an application. For example, the vendor, item, student, course, teachers and so on are all said to be the entity. Now, what do you mean by relationship? How do you relate it? Relationship are the meaningful dependencies between the entities. For example, vendor supplies item, teacher teaches courses, and then supplies and courses or relationship. For example, vendor supplies item, teacher teaches courses. Then here the supplies and courses are said to be the relationship. Now let us see what an attribute is about. Attributes specify the properties of relationship. For example, vendor code and the student name. So many different student names will be available. So each and every student name you call it as an attribute. Now my dear students, let us have a look on the symbols used in the ER diagram. The bigger level rectangle symbol denotes entity. A smaller rectangle placed inside a bigger rectangle, you call it as weak entity. A rhombus or a diamond sign is called the relationship. A rhombus within a rhombus or a diamond within a diamond is called identifying the relationships. Then a oval represents attributes. A oval which has a line within the oval is called key attribute. So whatever attribute that you place within the oval, when you are going to underline the attribute that is being placed in the oval, we call it as a key attribute. Then the other symbols are, we have an oval within another oval, a smaller oval which has been placed inside a bigger oval, which is called as multi-valued. Then you have a bigger oval which has been connected with small round circles, which is called as composite attributes. Then the oval, if it has been placed as a dotted line, as a dotted format, then it is called as derived attributes. Now let us see about the participation of entities. So here E1 and E2 are said to be two different entities, and R is said to be the relationship. So one entity is participating to multiple values, so that is called as 1 to n relationship. So this speaks about the total participation of E2 in R. Then this diagram is also similar, but over here it explains about the cardinality ratio of 1:n. So the participations can be either 1 to 1 or 1 to many, many to 1 or many to many. So that is called as a cardinality ratio. As far as this particular diagram is concerned, this E1, it transacts one time to many different transactions have been made. So that is called as 1:n for E1 and E2 in relationship R. These are some of the symbols that are used in the ER diagrams. Now let us see the example of the file organization. There are several kind of access methods that are used in the files. One is the sequential access, other one is the serial access, next is the direct access, and then you have an index access. As far as the serial organization is concerned, you have the batch kind of access. Then this batch access is possible in serial, sequential, and in the index organizations. Now what do you mean by batch? Okay. Next, as far as the direct and index organizations are concerned, they have an access of online access, and even the index has both batch and online. Now my dear students, what do you mean by batch access? What is an online access? Batch access is something like you schedule a task to get executed at a later time. As far as the online access is concerned, you give an input, you get an output. To elaborate, as far as this particular, I suppose you would have gone to several banks, you would have made the transactions. At the end of each day, people they take n number of copies as printout, which determines whatever transaction that has taken place within a particular day. So this printouts will be taken at the closure of the bank working hours. That is, after bank working hours gets over, the printouts come out. So that kind of transaction you call it as a batch access. Now, what is an online access? You go to an ATM counter, you insert your debit card, you type in withdrawal, you type in your PIN number. If it is valid, if your account has sufficient balance, when you give withdrawal, the amount will be coming out from the ATM machine. So that is called as online access, wherein it will be asking for a PIN, you enter the PIN, it will be validating. If the PIN is correct, it goes to the next screen. If the PIN is incorrect, it will ask you to re-enter the PIN, then again you enter the PIN. So it is two-way communication are being taken care instantaneously. So that is called as an online access. Now over to this file organization. Next is about the data organization. In the data organization, it is in the serial mode, it is again serial. In the sequential mode, it goes in a particular sequence, or it as well goes with your key value. Then as far as direct access is concerned, since as the name implies it is a direct, there is no access mode. Directly when you go, it gets access. So which means no particular order has been followed. As far as the index organization is concerned, it does both sequential and by index. Then flexibility in handling the inquiries. So this has been demonstrated or listed in this table. So you can have a look at this table, and the various file organization with the access modes have been determined in this table. Now let us see few examples for the serial organization, sequential, direct and index mode. So as far as the serial mode is concerned, the example is you have the ATM transaction queue, and as far as the sequential access is concerned, the example is payroll process script building operation, and as far as the direct mode is concerned, the example is online reservation system and the online banking transactions. Then as far as the index mode is concerned, you have the customer overriding and the customer billing will be taken out in the index mode. So this is about the file organization. So in all these organization modes, wherein only this direct access is said to be the fastest access mode when compared to other things. The second fastest is said to be index mode. So this speaks about the file organization. Now let us see the documentations that are used in the system design. We have a program documentation. The program documentation describes the input, output and processing logic for all the programming modules. The program documentation process starts in the system analysis phase and continues during implementation. This documentation guides programmers who construct modules that are well supported by internal and external commands and descriptions that can be understood and maintained easily. Apart from program documentation, we have the system documentation. In the system documentation serves as the technical specification. The system documentation provides the basis for understanding the technical aspects when modifications are made. Next is you have the operations documentation. The operation documentation contains all the information needed for processing and distributed online and printed output. Next is the user documentation. It includes instructions and information to the users who will interact with the system. For example, creation of the user manual, creation of the documentation, creation of catalog, creation of files. So creation of user manual and the help guides and tutorials. So these things are example for the user documentation. The user documentation is valuable in training users and for reference purposes. It must be clear, understandable and readily accessible to users at all levels. Next, let us see about the design strategy. The design strategy is been classified into 5 different kinds. One is called the top-down strategy. Next one is the bottom-up strategy. Third is structured design. Fourth is modularization. Fifth is structured charts. Now, let us see what a top-down strategy is all about. In the top-down strategy, the top-down strategy uses the modular approach to develop the design of the system. It starts from the top or the highest level module and moves towards the lowest level modules. The main module is divided into several smaller and simpler sub-modules or segments based on the task performed by each module. Then, each sub-module is further subdivided into several sub-modules of next lower levels. This process of dividing each module into several sub-modules continues until it reaches the lowest level module, which cannot be further subdivided or which cannot be identified. So, this is the diagram which represents the top-down strategy, wherein it is you have different levels, wherein you have a main module. This main module has been divided into sub-modules, and this sub-module is again been divided into sub-modules. So, if there is no further divisions possible, then this is called as a top-down strategy. Next, let us see about the bottom-up strategy. Bottom-up strategy follows the modular approach to develop the design of the system. It is called so because it starts from the bottom or the most basic level modules and move towards the highest level modules. Let us have a look at the bottom-up strategy. In the bottom-up strategy, you have a main module, wherein here, my dear students, let me say the difference between the top-down strategy and bottom-up strategy. In the top-down strategy, the main module is being divided into sub-module. The sub-modules are further divided into sub-modules, whereas in the bottom-up strategy, you start creating with a smaller module. You integrate 2 or more number of modules, and those 2 or more number of modules will form as a one other module. So, small modules will be called as sub modules, and those sub modules will be linked together or will be integrated together, and it will be formed as a single module, and you will be linking or integrating 2 or more number of module, wherein this particular module cannot be linked to other module. So, you have those many modules. So, again integrating all the modules together, you call it as a module. So, this bottom up strategy is a reverse of the top down strategy. In the top down strategy, you had a main module, you divided into sub module, that sub module you again redivided into sub modules, whereas in bottom up strategy you created small module of many different small modules, and you integrated 2 or more number of small modules into a somewhat bigger module. So, those small modules are called as sub modules, and from those sub modules you integrated and you had few sub modules, and integrating those sub modules and forming a main module, you call it as bottom up strategy. So, that is what is being described in this figure. Here you have a level 2 wherein you have the sub module of 1.1, sub module of 1.2. This gets integrated and it forms as a single module which has been named as sub module 1, and again you have submodule 2.1 and 2.2 which gets integrated and formed as a submodule 2. Similarly, you have submodule 3.1 and 3.2 which gets integrated into submodule 3. So, all these three submodules get integrated into a single module and it forms the main module. So, that is what is illustrated in this figure. Now, let us see what structured design is about. Structured design is a data flow based methodology that helps in identifying the input and output of the development system. The main objective of structured design is to minimize the complexity and increase the modularity of a program. Structured design also helps in describing the functional aspects of the system. In structural designing is used to graphically represent the flow of data and sequence of processes involved in a software development with the help of the data flow diagrams, which is shortly called as DFDs. Now, let us have a look at the structured design. So, here you have a system identification, the data flow diagram, and this data flow diagram has an access to the data dictionary. A dictionary is a place which has all kind of information related to the data. So, this DFD is being linked to this data dictionary, and you have structured English wherein it will be having a good sentence, it will be full of sentence. So, you have structured English, it is as well called as structured query. Then you have decision table, and this decision table is been again relinked to this DFD. So, this is a diagrammatic representation of a structured design. Now, let us see about modularization. Structured designs partition the program into small and independent modules. These are organized in top-down manner with the details present in the bottom. So, let us have a look at the advantages of the modularization. The advantages are: it is used in critical interfaces are tested first, it provides abstraction, it allows multiple programmers to work simultaneously, it allows code reuse, it provides control and improves morale, it makes identifying structure easier. So, this is about modularization. Now, let us see about structured charts. Structured charts are recommended for designing a modular top-down system. It shows a system module and the relationship between them. It consists of diagram consisting of rectangular boxes that represents the module connecting arrows or lines. This structured chart is broadly classified into two types. One is called as a control module, other one is a library module. The control module is a higher level module that directs lower level modules called subordinate modules. The library module is a reusable module and can be invoked from more than one point in the structured charts. Now, let us see the approaches in designing a structured chart and its objectives. The approaches of structured charts are transform centered structured charts. The transform centered structured charts are used when all the transactions follow the same path. Transaction centered structured charts. These transaction centered structured charts are used when all the transactions do not follow in the same path. And let us see the objectives of using structured charts. It is used to encourage a top-down design. It is used to support the concept of modules and identify the appropriate modules. It is used to show the size and complexity of the system. It is used to depict whether each identified function is a manageable entity or should be broken down into smaller components. Now, this is a diagrammatic representation of the structured charts, wherein you have module and it is being classified into submodules, and you have subordinate modules, and one of these submodule is being listed as a library module. Then let us see factors affecting the system complexity. A good quality software design is the one which minimizes the complexity and cost expenditure in software development. There are two important factors of system complexity. One is coupling, other one is cohesion. Coupling is the measure of the independence of components. each module should have simple clean interface with other modules, and that the minimum number of data elements should be shared between modules. Then the coupling is divided into two types. One is called high coupling, other one is low coupling. These type of systems have interconnections with program units dependent on each other. Changes in one subsystem lead to high impact on the other subsystem. As far as the low coupling is concerned, these type of systems are made up of components which are independent or almost independent. A change in one subsystem does not affect any other subsystem. Now let us see two things. One is about the coupling measure, other one is about the cohesion measures. As far as the coupling measure is concerned, you have control coupling. As far as the control coupling is concerned, when one component passes parameters to control the activity of another component. Stamp coupling, the data structures is used to pass information from one component to another. Data coupling, when one data is passed to the components that are connected by this coupling. Then about cohesion, the cohesion is the measure of closeness of the relationship between the components. It defines the amount of dependency of the components of a module on one another. The best modules are those that are functionally cohesive. The worst modules are those that are coincidentally cohesive. Let us see the worst degrees of cohesion. We have a logical cohesion. Logical cohesion is where several logically related functions or data elements are placed in same component. We have a temporal cohesion. Temporal cohesion is where a component that is used to initialize a system or set of variables performing several functions in sequence, but the functions are related by timing inward. Then we have a procedural cohesion. It is when functions are grouped together in a component just to ensure this order. We have a sequential cohesion. It is when the output from one part of a component is the input to the next part of it. Now let us summarize of whatever we have seen so far. We have seen the system design. The system design is the phase that bridges the gap between problem domain and existing system in a manageable way. We have seen about the different types of system design that was discussed in detail. We have seen the strategies of system design. We have as well seen several factors affecting the system complexity. Now these are some of the references quoted for your future study. Thank you.